Hello friends, सबको नमस्ते. So today this video we will train the SSD model on a custom dataset of traffic sign. So basically we create a traffic sign detection model using a SSD. So let's get started. So first we have to install this Roboflow to download the dataset from the Roboflow. Okay, so this is, you can say, the code which app just copy and paste to get a data set. Okay, and you can say the version is in YOLO format. So it's first downloaded, then it will unzip that. So let's get started. It will take time, so let me explain you this thing. The we can say when download a data set, it's you can say the name is traffic sign project 1, but we have to convert that into this traffic sign detection data set. So just for that we have to use import os. This is the old name, this is a new name. And if os.path exits means old name, means it's exit, and not os.path exit new name. If this exit and this not is not exit, only that at that time you have to rename this old name to new name. Otherwise folder remain successful. Otherwise it will see rename escape, source not found, or already rename. This way it's work. So let's get started. Let me just run this. It will now let me refresh it. You can see the dataset name is changed. Now let me show you. You can say these are the directories: train, test, and valid. Now let me see one more time. Let me show you one annotation file for clarity that what is happening here. It's taking time to load. So okay. Not this one. Something big one. Okay, only one annotation file is there. So do not worry. So here what we are doing, this is the annotation directory. And why we are removing it? Because during training, if the annotation file is empty or the length of the annotation file is not equal to the 5 according to the model which is required, so it will throw the error or the training get stopped at particular time. Okay, so to avoid this type of error during training, we have to remove the annotation file with size 0. So how we can do that? This is the annotation directory, this is the image directory. Okay, then before we print the length, means how many annotation file which we have before deleting the annotation file with size 0, then we zip over the annotation directory and the image directory, and we will get the annotation directory and the image directory both. Then we will list all the annotation file name using this OList directory. We will list all the annotation file name. After that we will also list image file name, okay, using a set. Then after that we will iterate over the annotation, like means file by file annotation file, we will iterate over it. For that if we use O for annotation in annotation. Then os.path.join. How to get the annotation file path? We have to first annotation directory, this one. Then the annotation means for loop annotation will be this way. We will get a complete annotation path. After that we just have to replace .txt to jpg to get the image path. So this way we're doing it. After that, if removing if image is missing, it might be possible that annotation file is there but image is not present. So we have to remove that annotation file. So how we can do that? Just use if not os.path exit, means image path is not exit but annotation file is exit. So remove annotation file. Okay. Then if remove empty annotation file, means if the annotation file is empty, so we have to remove those annotation file. If os.path size annotation file is equal to 0, it means annotation file is empty, so we have to remove those annotation file. Now sometimes you can see, okay, sometimes something is there but means annotation file is present but inside there nothing is there, means line is 0, line length is 0. So we have to remove those annotation files. So for that purpose we have to open the annotation file in read mode, and all thing is stored in this f. Then everything with read lines will be stored in this lines. If length of the lines is equal to 0, means we will remove those annotation file. Or it is malformed annotation files are those. Or it might be possible that something is written but it might be that this is not there, this is not there, so its length becomes 4. So, and if length is become 4 means bounding box details are not correctly there, because first is the, this is just a class id, other thing is for the coordinates. Okay, so this last length is 4, length is not 5, it means that particular annotation file is not proper, or is during training it will throw the error. So that's purpose we have to remove those annotation file also. Okay, now for that purpose we have to read line by line. If the, and after line dot strip dot split, give me the list, give me the list of all the digits present in the annotation file in the list format, but in the list of the string format. Okay, after that, if the length of data is not equal to 5, we will remove those annotation file. So you can see now, let me run this. Before it is 7311, but after 7243 means those annotation file is uh, have type 0 or something have problem in their those annotation file. And make sure if it will, you will not do that during training, it will throw the error, or sometimes we not understand what is what why this error is throwing. Okay, now these are the libraries which we required. Okay, those storage vision, and for ssd, fast to load the ssd model, data loader to prepare the dataset to load the model, to load the dataset. Okay, transformer to add a data augmentation, this is ssd classification had which we required. Utils to detail certain example box matches and lost. And this is the weight file which we using ssd 300, which is 16 weights. Okay, so this is a class, and why we create it? So let me explain you. Let me read this line. Custom dataset class is created to load images and their corresponding annotation file, convert them into tensor, and return them into a format that Python object detection model can understand during training. Okay, so that purpose because of this process, so that we can return the images and the label in a tensor format and make it readable by the readable during training. So that purpose we have to create a class. Okay, for that purpose, so class will be custom dataset. Then this is used init. Then these are the parameters: self, image directory, annotation directory, and transform. Self basically used to access the parameter throughout the class without passing them into as a parameter in the function. Okay, so if length self, we just use self annotation, it give me the length when we use length function. Get item basically return the, you can say, images and tensor. Now let me explain you. Okay, get annotation file name, we will using idx we get the annotation file name. Then we create an image path. How we create an image path? Just os.path join, then image directory, where just this was the image directory. The annotation, uh, removing last four character means .txt, we are not reading that. Instead of .txt we are adding .jpg. This way we create a image path. After that we will just image is equal to cb2.imd, read the image. After that, if image is none, it might be possible the image is not there, but using this it's not throw any error like that. But for the safety purpose, or you can say to handle the errors, just we use file error, file not found error. And we are reading the image into the using cb2, so we have to convert that into the rgb. So that's why cb2.cb2 color, it convert that image into rgb. After that we get image dimension, height and width, and after that annotation file. Now we have to read the annotation file, because those coordinates values. Okay, let me open one annotation file. Stick time to load. Yes. Okay, you can see the those values, this all values are in a normalized form, but we have to convert that into a pixel level format. So how we can do that? And this is a YOLO format, means this is a you can say x center, this is y center, this is box width, and this is box height. Okay, so we have to convert that into a pixel value format according to height and width of the image. So how we can do that? So first, for that purpose, okay, so that for that purpose we first to read the this is annotation file. Now we open, first we create the boxes and labels list, empty list. Then we open the annotation file in a read mode, and everything will be stored in this f. And we have to read line by line, so we have to loop for line by line in f. Line dot strip dot split, give me the list of all the digits present in the, you can say, okay, all the list, give me the list of all the digits, means there's 5, and 0.5117. This all digit will be given me in a string format. Okay. Okay, after getting this everything in a string format, we will first have to retrieve class id, class index. This is a this is class index, this first digit. So how we can do that? Just use data 0 and data 0, and then after getting this 5, and it data 0 in a string format, so how we have to convert it into int. For that purpose we use int here. Okay, now for getting x center we use data 1. Okay, data 1, and you can say if I will use int instead of float, then it will give me 0 only 0, only 0 value will give to me. But if I will use float, then it will be complete value 0.5172. And why we are multiplying it with width? Because we have to convert that into the pixel level format of the image. Okay, so y center, same way for the y center, same way for the box width, same way for the box height. Now to get the x mean, y mean, and x max and y max values, you can say x mean and y mean are the top left corner of the coordinates bounding box coordinates, and x max and y max are the bottom right corner bounding box coordinates values. So how we can do that? Just first to use box width divided by 2, then x center minus box width divided by 2 give me the x mean, and same way for the y mean, and same way for the x max and y max. And you will get, if you get confusing that how this calculation are doing, so first you have to set one example, means you have to set one bounding box bounding box, and set a coordinates values, then the x center, y center. And after that, when you will do manually those calculation, you will get understand how this calculation are going on. And this is then after getting this, we just append boxes dot append x min, y min, and x min, y max in the boxes list. Then the label will be appended to append. And here we are just adding +1. Why we are adding +1 here? Because the data sets which we are using, SSD 300 Coco data set, 0 index value is already fixed for the background. Okay, so that purpose we using class index +1. After that, we convert those into a tensor format. After that, we just if any data augmentation is applied to the images, we applied out those data augmentation using if dot self transfer, because initially it is none. If it is not none, it will apply the self image means data augmentation or any transformation to the image. Then it will create one dictionary with boxes and the labels, and it transfer. It will return the target image and a target. So this will be create the class. Now let me run it. Now this is model which I will explain you, so don't worry. Let me close it. Okay. First important thing, that how many number of classes which we have. You can see the number of classes which we have is 27. Okay, and 0 is not included here. So when we add 0 for the background, the total number of classes which we have is 28. Okay, so let me close this now. Now let me explain you. Here this is a function, create model function. We just create model function, and number of classes which we have is 28. I explain you why. 27 is for the data set and 0 for the background. To that purpose, when we add 1, so we will get 28 number of classes, size will be 640. Okay, now here we passing num classes will be initially during parameters, it's not required here. You will not number of classes which will be giving is 28, so don't worry here. Size will be 300, it's not required here. Now this is an important thing. Torch vision, from models, from detection, we importing SSD 300 base 16, and the weight file is SSD 300 base 16 weight Coco V1, and this is a pre-trained model. We are importing that pre-trained model. Okay, now after that, okay, one more thing. Let me pause this video. Now let me open some images so better explanation. Let me print the model for better explanation. Torch vision is not defined. Why? But we have run this cell. Oh, I have forgot to run this cell. Sorry. It will take time. Now after that, let me run it again. me run it again now. Oh, sorry. Spelling mistake is there. Now let me run it. Okay, now you can see. Okay, so you can see this is a regression head. This is complete. This complete is a regression head. Okay, and this is a classification head. And you can see here it's having a two head regression head and classification head. And every sequential layers are connected to the head. Now let me explain you. This is the SSD BNS 600 BG16. You can say the Coco data set. You can say already zero is fixed for the background. Now come back here. Now here, why I am retrieving the in channel use through the model backbone? Why I am retrieving this in channel? Okay, so let me explain you one thing that see, every sequential layer is connected to the head, and every in channel. Okay, sorry, not here. We are not retrieving the in channel. See, here we are retrieving the out channel. Sorry. Okay, but you can say that we are retrieving the out channel of each sequential layer, which act as a in channel for the classification head. Oh, sorry, for the classification head, or you can say the regression head. So at that purpose, this is the we can say the output which we retrieving it act as a in channel for the which we are retrieving. So that at that purpose we are retrieving the in channel. We retrieve the in channel also. Now we have to also retrieve the number of anchors. Now let me print this in channel also for better explanation that how it's coming, how we are retrieving the in channel. So wait for it. See here 5.2 1024 and 5.2 256 256, and you can say every last sequential last layer output channel act as an input channel for the head. So 5.2, see this is a first sequential. It start from here and it's ended here. It's 21 is end. So here 5.2 is the end output channel. So it act as an input channel. That's why it is 5.2. Initially it is 512. Now 1024. So here 1024 means second sequential start is second sequential start from here and end it here. This is the last layer of sequential. So here output layer is 1024. Output channel is 1024. So that's why it's having power 1024. 512. Now third is 512. Same here 512. You can say third is sequential. Now here last layer is 5.2 output. Now here second sequential 256, and here 256 is 2 times. So that's why here is 256 3 times. Okay, so this way it's calculating the in channel. We are getting the in channel. Now what is number of anchors? SSD uses anchor boxes at different aspect ratio and scale. The line retrieves the number of anchors generated by the model. Each layer has its own number of anchors. Now let me run this printer. Now let me explain you what is happening here. Okay, see here 4. Now we come to here. Here this is a classification head. And how this 364 is coming? Number of anchors which we have is 4. But according to the Coco data set, number of classes which we have is 91. So when you multiply 91 with 4, you will get 364. Okay, so 364 here is you can say output channel. Now here is 6 for the second layer. 6 is the anchor, number of anchors. So when you multiply 6 with the number of classes which we have is 91, so you will get 546. And same way the other calculation is going on. Now regression had only 4 values: x coordinate, y coordinate, width and height, or dx and dy and width and height. So these are the coordinates for the bounding box. So how these are calculations going on? 4, and when you multiply with 4 into 4, because 4 is number of anchor boxes and 4 is a you can say bounding box values. So 16 is come, And for the same for the second, 6 is the number of anchor boxes. When you multiply with 6 into number of anchor boxes is 4. Sorry. Now 6 is the number of anchor boxes, 4 is the coordinate. So 24 will come. So, but this classification head and classification and regression head is not according to our number of classes. So we have to change this. So because of that purpose, we retrieve in channel and number of anchor boxes. After that, replace the classification to according to the number of classes which we have. So how we are doing it? From model, go to head, then the classification head, then replace the classification head with the SSD classification head with in channel and the number of number of anchors and the number of classes. This way we get the model according to our number of classes. After that, we adjust the transformer sizing to match the input size. This is all the things. This is after that we return the model. So this way we get the model according to our number of classes. Now let me print this model, means the model according to our number of classes. So let me now you can see that 112 means which we have, how many number of classes which we have is 28. So when you multiply by 28 and you have previously the number of anchor boxes for the first layer is 4. So when you multiply, it will give me 144, and inside the second layer 6 is the number of anchor boxes, and you multiply with 28, you will get 168. And this 16, 24, 24, you know how its calculation is going on. So this way we get a number, we can say model according to our number of classes. Now, now we have to make the, you can say train image directory, train annotation directory. Then it will give me the, you can say list of all the annotation file name present at particular annotation directory. Now custom dataset, the class name we have here, we have created the object of the class, just passing the train image directory and train annotation directory, and a transform means we have just convert everything into a tensor format. Now what is the use of data loader? Create a data loader that load training data into batches of 4 batches, shuffle the data each epoch, and using a custom collect function to group images and target separately, useful when sample have different sizes, example in object detection. Okay, so this is a use of collect function, and this is also the use of data loader, that it basically make the data set convert the data into batches so that we can easily train that. Okay, so that's the use of data loader. Here we just pass a trained data set, means the object, batch size will be 4, shuffle will be true, and collect function, I have this is a use of collect function, this 2 line. Okay, so this way we create a data loader. Now let me run it. Now let me see how many number of batches we have. 1811. Okay, sorry. Train data loader gave me the see 1811 is a number of batches. Now when you multiply it with 1811 into 4, because 4 is a number of means in each batch 4 images will be present. So total number of images which we have is 7244. Okay, and where it's going on, see here 7243, but last batch have only 3 images. Okay, so okay, check. After that, this is okay. Now let me explain you one thing. See, here is number of classes which we have is 27, and I can't manually type every classes speed limit number 1. So how we can just create one list of the class name? Just using for that, you have to use the open the YML file with read mode, then yml.saveloadf, means everything will be stored in this data. In data.names, every class name is stored in this class name, and you print this, you will get the class name list. So this way we easily get the class name without manually work. Now let me run it. Now how we can get a, now we have to check the data loader. How we can check the data loader? I just want to plot 2 images, so I have to just use plot or subplots. 1 row 2 column means 2 images should be 2 subplots will be there, and figure size will be 10, 9, 10 and 16, 10 or 6. Figure x is just for the iteration over the subplots. Now we have to first create the iterator. For creating the iterator, we use iterator function. Just pass the train data loader. It will create a data loader. Oh, sorry, iterator. After that, we have to use the net function. It give me the images, means first batch or random batch images and target. That after we have to see. I just want to plot two images, so I just want to loop for two times only. For that purpose, IDs in range two. Then I have to just when you will run this, when you will just use this. Transformation, that this where it's going, see this, when you apply this transformation to the images, those images from the dimension height, width and channel, this two tensor function convert that into the channel height and width function. But for the plotation, we have to require height, width and channel dimension of the images. So for that purpose, we use image idx permute 120. It will convert the dimension from CHW to HWC, which is required. And all thing, everything is in a tensor format. So we have to convert into NumPy. So that's why NumPy is required. After that, we just make the copy of that images. Okay. After that, target idx. Okay. Means I can say every images is stored in this image variable. Every target means bounding box values every stored in this target value. Okay, now we have to retrieve the image boxes and labels. So how we can do that? We just use target boxes, and everything is in tensor format, so we have to convert into the NumPy. So that's why using NumPy here. Labels, everything have to convert into NumPy. So that's why we have use the NumPy function here. Now we have to iterate over the boxes and label using a zip. At the same time, because every bounding boxes has its own label, so that's why we have to use zip here. So after that, we just use we have to use box. It will retrieve me x min by min, y min, x max by max. And here you can see we first randomly generate the color. Random enters from 0 to 255. Random and rendered 0 to 55. It will randomly create one color. Okay. After that, why we are using label dot minus one? See, label start from 1 because 0 is reserved for the background class. But Python lists are 0 indexed. First element is at index 0. So we subtract 1 to correctly map the class label to the correct color list of the index. Okay. So why? Because this, you can say the class name list is started with 0 index value. Okay. So that's why we minus label minus 1. Now we have to draw the rectangle. For drawing the rectangle, we just pass the x min by min coordinate value, x max by max coordinate value, then the color, this is the thickness. Then this is just we have to put a text or label. How we can do that? Just class name label. Then these are the coordinates value where we have to put the text. This is a font, this is a scale, this is a color, and this is a thickness. Okay, now let me just show the images with access off. Now let me run it. See, run around. This is mandatory. Round. Round about mandatory, and this is general question. Okay, now let me run it again. It will give me different image again. See, bicycle crossing and road work, no entry. It's working very well. Now this is a part of training. Now let me explain you. Oh, one more thing. I already have a model which is trained on more than 10 epoch. So let me just use number of epoch one time only, just for the explanation purpose. So don't worry. Okay. So let's get started. Okay, so here we use TQ2M for the showing the processing var. How we can do that? Just use TQ2M for that purpose. We just display the training loss or store the training loss for every epoch. Now we will how many according to number of classes we loop over it. So we use number of epochs. The first line which we display is starting the training of the epoch plus 1. And then model is now a train mode. Then training running loss initially will be loss, means 0 0. Initially it will be 0 for each epoch. Initially its value will be 0. Now to apply the TQM, we have used TQ2M function. Then passing the train data loader. Then there's a length, and this is a you can say the text which we display. Leave true, yes. Then we loop over the P bar, then processing bar, you can say. Now image and targets. Okay. Now everything that has to be on a same model. Okay. One more line is I have missed, I think so. I have explained. I'm not explained where it is. Oh, I forget to explain this cell. So let me explain this cell again first. So here we use device. You can say variable. Why we using it? Because select GPU or a CPU during processing. So how we can get it? If storage.coda is available, then device variable will have coda. Otherwise it will have CPU. Now initially the initial model has, they see move the model parameter to the selected device. So this way for moving it, we have to use model.to then device. Now collect all the parameter the required gradients update, or you can see the parameter which are trainable. So how we can do that? For that purpose we use this line. For p in model dot parameter, if p dot required grade means if p dot required grade value is true, then it means that parameter is trainable, and this way we create the list of all the parameters which are trainable during training. Now here we are applying the optimizer. For the optimizer which we are using is SGD. This is the parameter which we are passing. This is a learning rate, and this is a momentum 0.9. Okay. Now learning rate control the update and momentum speed of the conversions. Now here we apply the scheduler. Set a learning rate scheduler that reduce learning rate by a factor of 0.1 every 3 epoch. How we can do that? For that purpose we use learning scheduler that step LR. Optimizer we are passing because optimizer is responsible for updating the you can say parameters, and learning rate is just for the speed learning rate of the model. Step size says 3. Step size 3 means after every 3 epoch it will multiply the learning rate value with 0.1. Initially the number of epoch value will be 1. So now let me explain you how the learning rate scheduler is working. So initially it will be 0.01. When it come to 3 epoch, after third epoch it will multiply it with 0.1 and you will get this value. After every third epoch it will be this. So this way the learning rate scheduler is working. Okay, now let me come to the training part. Okay, so here it will get. So model and the images and target should always on a same device. So how we can do that? For that purpose, we loop of all the images and moving it to the device. Same way we move to all the items, and you can say this target is a dictionary. So for that purpose, we have to loop for to loop, and this way we move to all the things into the same device. Now just we have to pass the images and targets. It will give me the dictionary of all the losses. Okay, now after that we sum of all the losses present in that loss dictionary using this for loop. After that, after summing of all the losses, and you can say this is iteration for the single batch. Okay, now see weighting update function formula. How the update weights are updated. So new weight, old weight minus learning rate into gradient. This is the use of the gradient here. So gradient tell us how much and in which direction a weight should change to reduce the loss. This is the use of the gradient. So optimize a zero grade, kill a previously stored gradient. And why we are using it? If we do not make this value gradient value 0 before the calculation of the gradient, then the previous batch gradient value will be accumulated to the new gradient value, and it will disturb the updation of the new weight. So that because of that purpose we use optimizer.zeroGrade to kill a previously stored gradient value. And after that losses.backward, basically here the calculation is going on. Mind my words, here the calculation is going on, no updation is going on, just a calculation. Optimizer.step basically update the weights using this function. Okay, now after getting the losses of first single batch, if I am talking about single iteration, okay, then losses.item, it will batch loss will be stored here. After getting the batch loss, training running loss, which store every epoch loss value, training which is initially 0, that then it will go to the training running store. It will accumulate to train running loss. Now after that scheduler step will apply here. After that we just calculate the epoch loss. How we calculate the epoch loss? The train running loss divided by the train running train data loader length. This way we append the train loss for every epoch, and we just display the train loss after this. So this is a training going on for the first epoch. Now we will save the model here. How we can saving the model? You can see for that purpose you use torch.save model.static and SSD is you can see the model name. So this will be save the model. Now we just see I'm just doing here for the single epoch one only, so it's, no flotation will be there. But this is a flotation for the 10 epoch. Okay, and you can see the loss is initially going down and down. Now how we can do that? How we can plot it? So for that purpose you use matplotlib, and you can say we range epoch range will be 1 length of train loss plus 1. Okay, then if after getting the epochs, the figure will be 8.6 plot dot plot, then pass the epochs means x value train loss by y value marker. Yes, we want to mark each value. Line width will be 2. Train loss which we have we can say maybe we have created the list, and epoch is a list of all the means how many x values. Now x will be called y value title, and this way we generate the loss. But I will not run this cell because it is just for the one epoch, so I will not run this. Skip the cell. Now this is a you can say testing of the model. So how we just have to test the model? Everything remain the same. Just call the function, number of classes, size 640. Now here we loading the model. First thing, device is important. I've explained you this line. How we load the model? For loading the model, we use model.torch state load state dict torch.load then the path of the model. Initially it is not one here. Okay, then that before it is in training mode, but now it is testing mode. So testing mode, model has to be in the evaluation mode. Okay, now everything has to be in the same device. So that purpose, now we have to plot the 16 images. So how we plot the 16 images? 4 rows, 4 columns. Figure size will be 20 by 20. Figure will be represented the entire subplot, entire plotation, not subplot. X are the x just for the iteration of the subplot. Then 2 tensor is required. And see one more thing, what you apply means what you apply during training, what you apply images before training, that data augment, that 2 tensor or anything size changes, size is fixed. If you have fixed the size or you have applied the 2 tensor, so same thing happens to be applied during testing, because otherwise it will throw the error. Okay, so that so during training, before training we apply 2 tensor, so we have to apply same thing 2 tensor here. But 2 tensor is required because training has to be converted all images, and target has to be converted in tensor format. Okay, so that's why it's required. Then this is a test directory. We have make the list of all the images present in test directory. Now for the 16 flotation, we have to loop 16 time. Then os.path join test directory. Then the randomly select one image file name. It will read the image. Means we have to get the image path using a using the this from using the pillow image function. We read the image, open the image, then we convert that into the MP array format. Why? Because everything has to, because this CV2 rectangle, CV2 put text require the image to be in a numpy format. So that's why we np.array, it converted into MP array format, and just we apply the transformation to the image. Then image.unsqueeze 0 to device. What is happening here? This two, what is happening here? During training, be passing the image into the patches format, means one dimension is added to the image. One dimension is added to the image. Okay, so during testing time, if we passing a single image, so we have to add one additional dimension, which is known as the batch dimension. Even if they passing the single image, so that's purpose image.unsqueeze 0 be passing the single, it will add one dimension to the image. Okay, then we just two device, you know what, that everything has to be on the same device. Oh, that purpose we require 2 device here. Then after that image tensor done with the torch no gradient. What does mean here? It means no updation of the gradient, or we can say the weight. Then we passes the image, then 0 index value give me the prediction of the single image. After that, how we are getting this prediction? See, prediction dot boxes give me the boxes detail. Dot CPU means everything has to be come to the back to the CPU. Then numpy, because everything is in tensor format, so we have to convert it into a numpy format. So that's why we require numpy, and everything has to here boxes values are in an int format. So S tab will be empty. Same way we retrieve the labels and the score. Now every boxes has its own label and has its own score. So we have to zip everything at one. Then we have to get the boxes, label and score. If a score is less than 0.5, continue means we do not want to the want to display those images, which is we do not want to display the bounding box around the sign if its score value is less than 0.5. Okay. After that, same thing, it will display the, you can say, select the color and everything I have explained you above in the code. Now let me see the code. Training has completed. Yes, training is completed. Model is saved. Now you can see it. Yes, you can see it. Now we can check the model which is trained on just one epoch. Test the model which is trained on just one epoch. Let me see how it's working. It's printing internal anchor value because in function above in a function we have we have two print statement. See, nothing is showing if if the model is trained on just one epoch. Now let me upload the model which is trained on one epoch and tiny epoch, and let me show the uh, result of that model. Now let me show the result of the model which is trained on tiny epoch. So this is a path name of the model which is trained on tiny epoch. Now let me run it. Wait for the second. See, traffic light, yes. Bicycle crossing, keep right. Say okay. This is a stop one. This is, you can say, no entry. You can increase the scale. Now let me first let me make it increase the scale here. Better to understand. See, slippery road, stop, speed limit 30 km per hour, 70, perfect. No right turn sign, bicycle crossing, general bicycle crossing, pedestrian road work. So this is a result of the model which is trained on tiny epoch. Okay, so if you want more code like this where we train the model on a custom data set, please like, share, and subscribe my channel. If you gain some knowledge, even a single word you have understand, so please like, share, and subscribe my channel. Thanks to all.